Hi, this is Alison Lew, Professor for Public Health 100 at Carolina University, and this is Lecture C. The subject today is macronutrients. So these are the relevant portions of the textbook. I accidentally clicked on one, so here you'll be able to see that. As you click down, you can see the chapters begin. This one's about lipids. So we're actually going to start with proteins. The importance of proteins is what we're going to discuss first. Proteins are vital to our well-being. Protein is a vital constituent to all of our organs in the body and is required to perform a vast variety of functions. Therefore, protein is an essential nutrient that must be consumed in the diet. So what is a protein? Proteins are macromolecules composed of chains of subunits of amino acids. So the amino acids are actually the building blocks of the proteins, is what makes them up. But then proteins are also called building blocks in the body sometimes as well. Amino acids are simple subunits composed of carbon, oxygen, hydrogen, and nitrogen. Food sources of proteins include meats, dairy products, seafood, and a variety of different plant-based foods, most notably soy. So the word in Greek, protein, means of utmost importance, and that's not a coincidence because they are of such vital importance in our body. So how do you form a complete protein? You'll hear the word complete protein in nutrition. Well, complete proteins contain all of the essential amino acids in proportions capable of promoting growth when they are the only proteins in the body. Remember in nutrition class, whenever you see essential, that usually means that it's something the body can't make on its own and it has to get it from the diet. Because there are things our body can make on their own out of the raw materials. But if it says it's essential, like essential amino acid, the body can't make that. It's got to get it from the diet. For a protein to be complete, all 9 essential amino acids, the ones that cannot be produced by the body or cannot be produced in sufficient quantities by the body, must be present in that protein. So that single protein has to have them all the essential ones. Remember, all proteins are composed of amino acids. There are 20 different amino acids total, so most of them are not essential ones. They're non-essential ones. And we need them all to make up the proteins in our bodies. So it's essential to get the amount of proteins that we need. So here we have information about the essential and non-essential amino acids. It's kind of going to compare. Essential ones are amino acids that can't be synthesized by the body, as we've already said, in sufficient quantities or at all, and non-essential ones are amino acids that can be synthesized in sufficient quantities to meet the body's needs. So here we have listed some essential ones and some non-essential ones. So how do we digest proteins? As your body digests proteins, it breaks them down into the individual amino acids. So you can think of that like building blocks. If you have a house of Lego blocks in primary colors, and we'll say there are 20 of those colors, so they're not just primary ones, there are more colors, then your body's going to break those down into the individual little block components, right? And then it uses those amino acids to synthesize new proteins. Here's a reminder about digestion, and it gives specific information about the digestion of proteins. Now we're going to talk for a moment about albumin and how it is a blood protein. So what do we need proteins for? For collagen, a fibrous protein found in our bones, skin, ligaments, tendons, blood vessels that's strong and flexible. Collagen makes up quite a bit of our bodies, and we need proteins to make that. We also need proteins as enzymes. Proteins are responsible for conducting many of the chemical reactions in the body. That's what enzymes do. And so proteins make those up. And also for making hormones, which are very, very important to our body processes. There's all kinds of hormones too. There's thyroid hormone. There's hormones related to reproduction. There's many. There's insulin. We also need proteins for fluid and acid-base balance in the body. For example, blood albumin keeps the blood inside the cells. It keeps the fluid of the blood inside the cells to maintain an environment and decreasing the chances of cell swelling that can lead to cell death. So that albumin actually protects the fluid balance in our body. We also need proteins for transportation. Albumin in the blood binds to various substances and carries them throughout the body. And then we have energy production needs. We actually break down protein for energy. So, what are the consequences of a low protein diet? A low protein intake has several health consequences, and a severe lack of protein can even cause death. Although severe protein deficiency rarely occurs in children and adults in the United States, it is estimated that more than one half of the elderly in nursing homes are protein deficient. So there are people that are protein deficient in the U.S., and there are certainly people in the world that are protein deficient. And we're going to talk about that as we go along. So a lot of our protein deficient individuals in the U.S. are elders. Protein deficiency in other countries. So in underdeveloped parts of the world that just don't have adequate access to food and the types of foods that are going to provide the proteins, where there's a lot more poverty and malnutrition, the consequences of protein deficiency kills many children. So two diseases tend to develop. There's kwashiorkor and there's marasmus. So with kwashiorkor, we have edema of the feet and abdomen, poor skin health, low muscle mass, poor liver function, and with marasmus, we have emaciation, poor skin health, and growth retardation. So the word background, the word origins for these are that kwashiorkor comes from a word from Ghana that means rejected one. And the reason for that is it often occurs in children that have just been weaned, and those children are usually weaned from their mother's milk because a new baby has been born. And so when that happens, they start to consume a diet that's very, very low protein. And when they do that, they can develop this problem. Marasmus comes from the Greek word for starvation. So this is an example of an individual child who's developed kwashiorkor, sadly, and you may see the signs of that in the very thin extremities and arms shown, the swelling of the belly, and foot swelling may also be present but is not shown. There was actually a famine in a part of the world when I was a young girl, and very, very ill-informed people would sometimes say, well, those people can't be starving because they have they have this belly, right? They have belly that seems larger. And actually, that is just the protein problem that they have as a result of the type of malnutrition they have, this kwashiorkor. They develop edema in the abdomen and feet. They were certainly not well nourished, and many, many of them died. So that was just a very, very rather ignorant way to respond to a famine taking place in the world. Of course, many other people were trying to help with the famine, but I just remember that being so sad that the people were so ignorant that they didn't understand that that was a protein deficiency. I didn't know that till much later in my life, but when I learned it, I thought about the response that I had heard as a child to that famine, and it made me very sad. So marasmus is characterized by emaciation. You can note the ribs showing prominently in this particular individual, and then the skin looking like it's not healthy. And then these individuals are very small. Like if they're children, they're undersized for their age. And of course, I want to express that these photos are very old. These are the ones that get shown most of the time when people are talking about these diseases. But we always want to be respectful of the fact that, the people that these are real people in these pictures, and maybe even succumb to starvation, and that is extremely sad. And it still happens today over and over and over again. We have not been able to solve this problem, and it happens in different places in the world, kind of cyclically. It doesn't happen in the same place all the time, but it's happening somewhere all the time in multiple places. So kwashiorkor and marasmus often occur in the same person at the same time. That's why some of the things tended to overlap, and some of that is because it often occurs in the same person at the same time, but not always. So I want to just briefly touch on the fact that alcohol is actually considered a micronutrient too, or macronutrient too. Your book doesn't really emphasize it, but I want to talk about alcohol for just a minute. The consequences of too much alcohol are as follows. There's shorter-term risks like injuries, violence, poisonings, risky behavior, and subsequent results, poor pregnancy outcomes for pregnant women. And just be aware that alcohol, while it does provide calories, if people are relying on alcohol as a macronutrient, they are actually not getting a whole lot of micronutrients from the alcohol as a macronutrient. Therefore, they often develop, this is the important part, they often develop nutritional deficiencies. So in someone that, say, has alcohol dependence, is an alcoholic, you will see very significant vitamin deficiencies in those individuals. They're often very malnourished, even though they may not look malnourished because they're getting enough macronutrients from those calories. They have severe deficiencies in their micronutrients. All right, so let's talk about carbohydrates next, another macronutrient. Worldwide, carbohydrates are a major component of people's diets. They're pretty much the major component. So carbohydrates are the perfect nutrient to meet the body's needs. They nourish the brain and the nervous system. They provide energy for all the cells within reasonable calorie limits, and they help keep the body fit and lean. They're really our source of the greatest number of calories in most diets. We have digestible carbs and indigestible carbs. So the digestible ones provide bulk in foods, they provide vitamins, they provide minerals. The indigestible carbs provide fiber. So when they say, oh, you need more fiber in your diet so you don't develop constipation and it helps with these other problems and that could develop, that's what they're talking about. They're talking about these indigestible carbs. They have many benefits. So let's talk for a minute about plants, because plants make glucose. There's also where carbohydrates come from. And when we eat the plants, we use the glucose to nourish and fuel our bodies. There are simple, fast-releasing carbohydrates, which are also called sugars colloquially. And the examples of those are fructose, glucose, and lactose. They stimulate the sweet taste that we associate with simple carbohydrates. They can be categorized as monosaccharides or disaccharides. And monosaccharides are a carbohydrate made of a single sugar molecule. The disaccharides have two, and they're linked together. Then we have the complex or slow-releasing carbohydrates. Those are polysaccharide long chains of monosaccharides put together that may be branched or unbranched. There's two types: starches such as beans, root vegetables like potatoes and grains, and then there's dietary fiber like pectin and cellulose. So generally in recommendations for nutrition, we're told to eat more complex carbohydrates than simple ones because the complex ones are healthier. So let's focus on dietary fiber for a moment. It's very good for our bodies. We do not make any enzymes to help us digest the dietary fiber, and the bacteria in our intestines don't digest it, or they do digest it instead. So the bacteria is actually what feeds on the dietary fiber. Remember how we talked about bacteria exists in our gut, in our GI system, and it's supposed to be there and it's good for us. Well, the bacteria are actually feeding on these dietary fibers. There's two types. There's water-soluble and water-insoluble, and those mean what they sound like they mean. One is soluble in water and one is not. So here's an educational video about how the digestive system works. If you would like to click on that, you can learn more about the digestive system. And an educational video about carbohydrate metabolism, and that will give you more detail. So what about controlling glucose in our bodies? That's really important for our health. Remember that glucose levels in the blood are tightly controlled. Having either too much or too little glucose in the blood can have health consequences, and glucose regulates its levels in the blood with a process called negative feedback. So glucose is essential, but blood glucose levels being too high or too low is detrimental to human health. And you may have heard of people who develop type 2 diabetes or type 1 diabetes, both of which are problems where the blood glucose is too high. They're fairly different in nature, but they both have a too high glucose as sort of the salient characteristic. So let's talk for a moment about glycemic index. You may have heard of the glycemic index of food. The glycemic responses of various foods have been measured and then ranked in comparison to reference foods, usually a slice of white bread or just straight glucose, to create a numeric value called the glycemic index. So a diet in low glycemic index foods has been shown by epidemiological and clinical trial studies to increase weight loss and reduce the risk of obesity, type 2 diabetes, and cardiovascular disease. And these are diseases that we want to decrease because they're so common in society and they cause disability, death, and lots of problems for people. So having a glycemic index on a food can tell a person relative to other foods, is this healthy in terms of its glycemic release, like how quickly it's going to release in my body, because slower is better. So let's talk about the functions of carbohydrates in the body. There are many. We have energy production, energy storage, building macromolecules, sparing protein, and lipid metabolism. And what that means by sparing protein is we're going to use the carbohydrates as our quick way to have nutrients. If we have to break down protein that's stored in our body, we will. Our bodies will do that, but that means breaking down things like muscle. It could even mean breaking down things like cardiac muscle if things are bad enough. So we don't want our bodies to break down important muscle structures in our body. To keep that from happening, we want to make sure we have a balanced diet that includes carbohydrates. For more details on carbohydrate function, I encourage you to look at this information from the textbook. Now let's talk about lipids. What are lipids? Lipids are fats. And lipids are also a family of molecules composed of carbon, hydrogen, oxygen. But unlike carbohydrates, they are insoluble in water. Lipids are found predominantly in butter, oils, meats, dairy products, nuts, and seeds, and in processed foods. Lipids are important molecules that serve different roles in the body. And the primary functions of lipids in the body are to serve as a structural component to all cell membranes, to function as energy storehouses, to function as an important signaling molecule. We'll discuss the following lipids in this lecture: triglycerides, fatty acids, phospholipids, and sterols. So phospholipids are found in animals and plants. Sterols are mostly manufactured by the body. The most important of those is cholesterol. And then 95% of what we have is triglycerides. And those are sources of fats and oils found from plants and animals, such as olive oil, nuts, corn, milk, and cheese. So let's talk about this bigger group, the triglycerides. A glyceride molecule, together with three fatty acid chains, forms a triglyceride. Tri means three. They're thick, smooth, and syrupy, and they're used widely in the food industry. They're found in our bodies as well as in our food. And if you would like to learn more about lipid metabolism, I encourage you to click on this educational video about that. So fatty acids are vital for the normal operation of our body systems, and fatty acids also determine whether a compound is solid or liquid at room temperature. And that's a big clue for us as human beings eating, because fatty acids that are solid at room temperature are less healthy than fatty acids that are liquid at room temperature. So that means butter, which is essentially solid at room temperature, or lard or Crisco, which is vegetable shortening, which are solid at room temperature, are less healthy than things like olive oil or corn oil. Those are liquid at room temperature, and they are more healthy for our vascular system. And remember, most people die of heart disease, which is a vascular disease. So we want to try to eat the healthier fatty acids, and those are the ones liquid at room temperature. So fatty acids are carbon chains with a carbolytic acid group on one side and a methyl group on the other side. The carbon lengths and degree of saturation vary from one fatty acid to another, and that's important to know because we are supposed to eat less saturated fats and more unsaturated fats. So when we're trying to eat a healthy diet, or if we become a healthcare professional someday, we're trying to educate people about a healthy diet, then we want to encourage them to know the difference between saturated and unsaturated fats and to eat the ones that are unsaturated and to decrease the ones that are saturated. And that helps keep their heart healthy so they don't have a heart attack. And then even if it doesn't prevent a heart attack forever, it can delay a heart attack to a later age. When the carbon chain length is shorter, the melting point of the fatty acids becomes lower and the fatty acid becomes more liquid. So here's this butter that I was mentioning. This happens to be a spreadable butter with canola oil. So that one's going to be a little healthier than the ones that are just solid, but not as healthy as just plain canola oil would be. Foods that have a higher percentage of saturated fatty acids tend to be solid at room temperature, like chocolates and meats. Those are less healthy. And then shifting fat consumption from saturated fats to unsaturated ones is an easy tip to help you stay healthier for your vascular system. And so this is olive oil, and that's going to be healthier than the butters, the Crisco, vegetable shortening, or the lard. So what are trans fatty acids? Trans fatty acids are mostly not found in natural foods. They are formed by a process called hydrogenation, and hydrogenation is often used to make liquid vegetable oils more solid for use in the food industry. So why is this important? Trans fats are associated with an increased risk of coronary artery disease, according to the Nurses' Health Study. Now, this was a huge study. There's some links here, but this is a huge study. Just many women in the study. And they were followed for a long time. They used nurses because at the time that was a good population to use for understanding and following the guidelines of the study. And they followed them for so long. And what they found was that these trans fatty acids in the diet really increased the coronary artery disease risk. So we have very good data on it. More has been done since then. So essential fatty acids, we're going to see that word essential yet again. Essential means it has to be obtained from food. The body is capable of synthesizing most fatty acids it needs from food. However, there are some fatty acids the body cannot synthesize, and these are called essential fatty acids. We have to get them from our diet. So, two essential fatty acids, omega-3 and omega-6. There's a fact sheet there if you want to click on that. Good sources of essential fatty acids are fish like tuna and salmon, seeds like flax seeds, nuts like walnuts, and plant oils like soybean, flaxseed, and canola. Now, deficiencies of these are pretty rare. We don't see it a lot unless someone is overall very malnourished or on a very limited diet. But it's important to know that these are the essential fatty acids. Okay, let's talk about phospholipids for a minute. Phospholipids are very interesting. The chemical structure that allows them to be water soluble is very interesting because I remember what we talked about, lipids aren't water soluble. Well, phospholipids are kind of water soluble, not entirely, but a little bit, and we're going to talk about why. So they bind together in the body to form cell membranes, okay? So this is what makes up our cell membranes, these phospholipids. Remember, the cell membranes are semi-permeable, so things can go back and forth between them. And we're going to see how that happens is largely about phospholipids. So there is an amphiphilitic side, sorry, that word is hard to say, with a fatty acid, and that is water hating. They do not like it. And a side that's water loving. So that side likes water and tends to stay close to water. And what that does is it allows cell membranes to have the tails on one side, the heads on the other side, and you'll see how that makes them a good cell membrane that can be semi-permeable. These phospholipids are ideal emulsifiers. They keep oil and water mixed together, right? Which shouldn't be possible, but it's a little possible, all because of phospholipids. And the body can make phospholipids, so that's important to know too. So if you have salad dressing and it has oil and water in it, it has oil and then it has water with some spices or whatever, and you shake that up and it mixes together, then it's going to separate again, right? Well, phospholipids can actually emulsify that and keep it mixed together all the time so it wouldn't separate. So phospholipids have an important role in the body. Phospholipids bind together to form these cell membranes like this. So we have the cell, then the lipid bilayer. So it's showing you like a little piece of what the cell membrane looks like. Of course, it's tiny, tiny. The cell is tiny, tiny. And then these molecules are really, really tiny, tiny. So we have a phospholipid molecule with a hydrophilic head and then a hydrophobic tail. So the hydrophobic tail doesn't like water. The hydrophilic head likes water. So it stays close to the water, okay? And that allows the tails to form sort of the inside of the membrane and the heads to form the outside on either side, the cell side and the outside of the cell side. So that's really, really important. All of our body is made up of cells and they have cell membranes, and there's where they come from. You have to have phospholipids to have these cell membranes. All right, sterols is next. Sterols are structurally not similar to other lipids we've been discussing. The most famous sterol is cholesterol because of its role in the development of coronary artery disease. It gets talked about all the time in nutrition. Cholesterol is actually essential to many body systems. You can't say it's bad. It's not bad. It's important and you need to watch out for it, but cholesterol itself is not evil. We have to have it. It is problematic when it accumulates too much in the blood, though, and that's where we get an increased risk of coronary artery disease. The body can and does make cholesterol. In fact, most of the cholesterol in the blood doesn't have anything to do with what we eat. It has to do with just the body and how much cholesterol it's making. So here's the classification of the major types of lipoproteins. Then is based on their densities. The density range is shown. You can see that HDL is the smallest, the LDL is bigger than that, the IDL and the VLDL, and then the chylomicrons. So LDL is considered the good cholesterol. LDL is considered the, quote, bad cholesterol that we want to have less of when we have our lipid protein or lipid profile drawn at the doctor's office. And then, when we've just eaten a fatty meal, chylomicrons are what's, you can actually hold up a tube of blood and see. You can actually see chylomicrons. They're shiny, but they're still really, really tiny. It's just that you can see that they're in there because of that shininess to some of the blood fluid. And those are the chylomicrons floating around. So what do cholesterol numbers mean? When you get your blood drawn, you have your cholesterol checked in what's called a, quote, lipid profile test. What do you find out from that? So low-density lipoprotein, or LDL, is a, quote, bad cholesterol. Having high levels of LDL cholesterol can lead to plaque buildup in your arteries and result in coronary artery disease or stroke, and we want to avoid that as the major killer. And then HDL, which is the high-density lipid proteins, is the good cholesterol, quote unquote. And HDL, we want to have higher numbers of that because higher numbers of that can indicate that we have a lower risk of heart disease and stroke. And then we have the triglycerides, which are a type of fat in your blood that your body uses for energy. The combination of high levels of triglyceride and low HDL cholesterol or high LDL cholesterol levels can increase your risk of heart attack and stroke. And there's all kinds of studies that have been done and scales that clinicians use to try to help people understand their risk of coronary artery disease and stroke related to their lipid profile. There's also the total cholesterol, which is a little less informative, but is still good to know about. The total cholesterol is the amount of cholesterol in your blood based on your HDL, your LDL, and your triglycerides. But it's even more important to know what makeup you have of HDL, LDL, and triglycerides. But if you have a high total cholesterol, that's very informative to your clinician too. So optimum cholesterol numbers would be a total cholesterol about 150. So if it's 200, 220, 250, that's high. An LDL cholesterol about 100 would be considered optimal. An HDL cholesterol at least 40 in men and 50 in women is considered optimal. So this one, if it's higher, if yours is, 60, that's really good. Triglycerides, you want to have that less than 150. So if it's high, then your clinician may talk to you about that and talk about how to fix that. How fiber decreases cholesterol? Well, fiber does decrease cholesterol, and it does that through this process involving the liver and bile and the dietary cholesterol actually not making the impact it would make, because this process through the liver and digestion actually makes the cholesterol be excreted instead of being in your blood and therefore absorbed and getting in your vessels, staying in your vascular system. It actually helps to get rid of it instead. So let's talk about the importance of storage for a moment. This is directly from our textbook. Before the prepackaged food industry, fitness centers, and weight loss programs, our ancestors worked hard to even locate a meal. They made plans not for losing those last 10 pounds to fit into a bathing suit for vacation, but rather for just finding food. Today, this is why we can go long period of time without eating, whether we're sick or really, really hungry, or our physical activity level has increased and there's simply no food available. Our bodies have a fuel reserve for a rainy day. So the fact that we have plentiful food in some places today, like most of us have plentiful food in the United States, not everyone, there's certainly a hunger problem, it's real, but in places where people have a plentiful amount of food, we actually kind of have a problem with that because we tend to overeat it and cause obesity and then increase our risk of coronary artery disease. But there was a time when that wasn't happening nearly as much anywhere. And people were usually on the verge of malnutrition most of the time. And being able to store food as fat was very important to maintaining through the winter, maintaining through times where there was no food available, etc. So personal health choices today. Eating more fiber is really important to a healthy diet. Eating more fatty fish because it contains more heart-healthy fats like omega-3s is really important to a healthy diet today. And eating nuts because they have higher amounts of unsaturated fats can improve your cholesterol numbers. So that would be a really good thing to do today. Of course, you have to watch what other fats are in your diet and kind of replace unhealthy fats with the healthier ones. And then using olive oil and other heart-healthy oils in place of unhealthy oils can be a big game changer for a lot of people too. And don't forget about inflammation. Increasingly, inflammation is being seen as a big factor in the development of vascular disease, and many heart healthy choices involve decreasing inflammation. But very few of us think of inflammation when we think about our risk factors for heart disease. So some of the things that they're telling us not to eat to prevent heart disease, one of the reasons they're telling us to do that is because those things actually cause inflammation, and that inflammation in our vascular system will actually increase our chances for vascular disease. As our body tries to repair the vascular system, it actually does things that increase our chances of getting clots and having atherosclerosis, and that leads to heart disease. So decreasing inflammation is good. So as we're making choices, we want our fats less than 30 to 35% of our calories for adults, slightly more for children. The children need a little bit more fat. And then less than 10% of calories being from saturated fat. So you want that saturated fat to be lower. Here is a food label where you can see that the saturated fat is listed, the total fat is listed. We want to keep trans fats and hydrogenated and partially hydrogenated fat consumption as low as we can. Now, it's a little bit tricky on food labels because they list trans fats and it usually says 0 grams. However, the food industry is allowed to put some trans fats in that food because the trans fats actually help to increase the shelf life of food, and I don't know exactly how they got permission to do this, but they can put 0 if it's less than 1 gram. So there could be 0.8 grams and they can still put 0, but there's still trans fats in that food. And the way you tell if there's any trans fats in the food, if you'd like to eliminate them as much as possible, is to look in the ingredients list and look for things like partially hydrogenated vegetable oil and hydrogenated oils, because those words mean trans fats. When consuming dairy and meat, select lean or low-fat items to decrease your saturated fat consumption, and that will help you to have a healthier diet fat-wise. And I think that is our last slide. I want to thank you for being part of this lecture today. Please make sure to do your questions for this assignment. And in-person students, I'll see you in in-person class. And then also our online students, please do your interactive discussion question for this week. Thank you so much. See you in the next lecture.